Good morning, friends. Welcome back to the session on calculation of scientometric indicators using MS Excel. In the first part of this presentation, I was able to demonstrate you how MS Excel can be used for calculating a good number of, I think, 10 plus scientometric indicators. And in this presentation, I would like to concentrate on the remaining scientometric indicators. Before I proceed, I would like to seek for your apology because there is a small correction or error in the calculation of annual ratio of growth and annual growth rate, which I found out. So you just forgot about whatever we discussed in the last session, and you take into account of this formula for calculating annual ratio of growth and annual growth rate. Fine. And the formula is for annual ratio of growth. The formula is current year output slash last year output. Fine. If you take annual ratio of growth for this 1993, it says current year divided by last year. What is current year? 53 divided by 55. So what is the annual ratio of growth? 0.96. Okay. It means that if 55 is taken as 100, then 53 is equal to what? It will be 0.96. So when you're comparing your current research output in respect with the previous year research output, you could see that you are able to achieve only 96% of what you were able to achieve last year. Last year, you achieved 100%, 55. This year, only 96%. That means you got only 53 research papers. Fine. But how you have to write the answer? Since the annual ratio of growth, you should write the answer in the form of a ratio. That means 0.96 is to 1. 0.96 is the current annual ratio of growth. 1 stands for 55. That is 55 is equal to 1, 53 is equal to 0.96. So this way you have to write the answer as a ratio. Then as far as annual growth rate is concerned, current year output minus last year output divided by last year output. Fine. That is 53 is current year minus 55 is last year. That means if you're having a negative growth, we had 55 last year, this is only 53, so minus 2. So minus 2 divided by last year output 55. So you get the minus 0.04. So we have a annual growth rate which is in the negative form. So these two corrected formula you can use for calculating annual ratio of growth and annual growth rate. Okay, I think that's clear from my part. Now let me go on to the remaining scientometric indicators. Let me start with this DCI. I think we had seen till this particular AAPP. Now we'll start the DCI. DCI stands for Domestic Collaborative Index. So when the authors are collaborating papers jointly with others, either they can have domestic collaboration, they can have international collaboration. So domestic collaboration means how many papers I contributed joining my hands with other authors who are in the same country. What is international collaboration? How many collaborative papers I have published by joining hands with the authors of other countries than my own country. Fine. So this DCA talks about the relative collaborative papers of your country, your single author to the rest of the world, to the rest of the world of authors. Okay. Let me see how to calculate this domestic collaborative index for countries. The same formula you can use for calculating domestic collaborative index of authors also. Fine. The formula says that there are two components as usual. Locally co-authored papers from a country divided by total numbers of papers of the country. This is one portion. So another portion, locally co-authored papers of all countries divided by total number of papers of all countries. Fine. So total number of papers of all countries. If you find out the ratio between these two, and that is a domestic collaborative index. For example, in India, total output is 200. Collaborative output is 160. Out of 160, 130 we had local collaborations and 30 we had international collaboration. So how to calculate domestic collaborative index for a country like India? What is the formula? It says that F17, what is F17? Locally collaborated authors of India divided by D17. What is D17? Total output of India, that's 200. You get the answer. Divided by 1950. What is 1950? total number of locally collaborated authors and contributions of the entire world. You take all the countries, totally 1950 papers are created out of local collaborations. So 1950 divided by 267, 2670, there's a total output of all the countries taken together. So what is our DCI? 0.89. Okay. So this tells you, while you are comparing the world average in terms of locally collaborated research output, where do we stand? If you compare the DCA of other countries, you can see here, USA 0.91, Japan it is 1.10, because out of 480 collaborative papers, 401 are locally collaborated. So their DCA is higher number and it is more than the world average. Fine. So this we can calculate domestic collaborative index. Then let me move on to ICI, International Collaborative Index. Same thing. That is out of the total collaborative research work, how many papers you have collaborated with the authors of other countries. So if you see the proportion, you will get ICI. So you need four components: globally co-authored papers of a country divided by total papers of the country. This is one portion. The second portion, globally co-authored papers of all the nations and number of papers of all the nations. This is another portion. If you divide this by this, you will get the ICA. Let us, it's an example. It is like India, total output is 200, collaborative output is 160, out of which 130 we have locally collaborated and 30 we have international collaborated. Now how to calculate ICI? F14, that means how many papers India has collaborated with other countries, 30 divided by C14. What is C14? Total output of India. How much? 200. So 30 divided 200 is one portion. But second portion, 520. What is 520? If you take the contribution of all the countries together, how many papers were collaborated internationally? How many papers? 520 papers. So 520 divided by 2670. What is the 2670? Total output of all the countries taken together. So what's the answer? We get 0.77 is our internationally collaborative index. So if you take China, it is 1.03. If you take Canada, it is 1.46. That means if ICA is equal to 100, means that we are at par with the average of the world. If DCA or ICA is more than 100, it means that our coordinated efforts are higher than the world average level. See, on an average, if world has got X as their collaborative coordinated efforts, our performance is more than the average if ICA is more than 100. If ICA or DCA, if it is less than 100, it means that our collaborative efforts are not equal to the world average collaborative efforts. Fine, that's what DCA and ICA all means. Then comes averages. You can cover a lot of averages. Average number of papers per year, average number of cited references per year, average number of cited references per year, I think, per paper per year, fine. Citation per paper, self-citation per paper, self-citations per year, simple calculations. And if you can calculate total number of papers and total number of years, then you can calculate average number of papers per paper. Very simple in MS Excel. So MS Excel can be used to calculate even this kind of very simple calculations too. Then let me go further. RCI stands for relative citation impact. You take your citations, the citations what you receive for your output, maybe an individual or maybe a country, and you take what is a global output of the entire nations or entire authors. If you see the proportion of these two concepts, then you'll get a relative citation impact. Fine. So what the formula? It says that if you want to calculate relative citation impact of India, the formula is India's citation count divided by total world citations. And there is a mistake. Yes. India citation count divided by total world citation. This is the first portion. And second part is India's production count divided by world production count. If you take these two and divide, you will get relative citation impact. It's very simple. Okay. For example, let us take an example here. You take India. India has got 120 papers, and India got 240 citations. If you take the entire world, we have 1,000 papers, and we got the world has got 4,800 citations. Right? How to calculate RCI? Very simple. D29. What is D29? D29 is the citations received by India, 240 divided by 4,800. What is that? That is the total number of citations received by all the countries during a given period. So 240 divided by 4,800, first portion of the formula. But second portion, C29. What is C29? These are India's production. India has produced 120 papers divided by 1,000. What is 1,000? 1,000 is the total number of papers published by all the countries during given period. Fine. So what is the relative citation impact of India? It is 0.42. If you take China, it is 1.31. It means that if our RCI is equal to 1, it means that we are at par with the world average. If it is less than 1, it means that our relative citation, the number of citations India receives for her papers, the average citation is not at par with the world average citation. Fine. And this way, you can calculate a relative citation index of authors also. For example, there's an author, okay, he published 51 papers and he got 1816 citations for his 51 papers. And totally all these authors together, they contributed 259 papers. And for all the 259 papers, they could get 6654 citations. Now I can calculate relative citation index for each and every author. For example, let me do it for Ho. D47. D47 tells what is the citations Ho received divided by 6654. That is total citations of all authors taken together divided by these two components. C47, number of papers published by Ho divided by total papers published by all the authors. So this tells you the relative citation impact of each and every author. You can see here. This gentleman V has got 2.23, so he has got 2 times than the average citations of all the authors, and this is 0.34, 0.36. Their average citation is comparatively, when they're comparing with the average citations of all authors taken together, the performance citation of these authors are less than the average. So you can calculate relative citation impact using this formula either for authors or for countries. Now, science production index is very simple to calculate. It just tells you what is the percentage of your contribution to the world research output in a particular given discipline during a particular period. Okay, for example, you take India. India has published 100 papers, and all the countries, maybe for example, this is a research output of all the countries in COVID-19. Only 5 countries have produced papers since beginning till this year, 1170 plus total output. And what is science production index of India? It's very simple, 100 divided by 1170. What is the science production index of China? It says C9. C9 is 200 divided by 1170. This way, you can easily calculate science production index. It's nothing but the percentage of papers contributed by a single country in the total research output of the entire world. Fine. Science production index. Then comes publication efficiency index, and this tells you how many citations you received in a year and how many papers were published in a year. Based on that, they got publication efficiency index. So you publish papers, and what is the efficiency of your publications? It depends on how many citations your papers are going to receive. So based on the number of citations your paper receive, your publication efficiency is calculated. Fine. So how to calculate? It's very simple. Total number of citations in a year divided by total number of citations for all the years. This first part of the formula. Total number of publications in a year divided by total number of publications for all days. Another part. You divide first part by second part, you'll get the publication efficiency index. Let us see here. You take 2001, the publications are 1366, the citations are 31304. Fine. How can you calculate this publication efficiency index of 2001? It goes this way. D26. What is a D26? Number of citations for 2001 divided by 519562. What is that? That is the total citations of all the papers in all the years taken together. This first part of the formula divided by C26. What is that? Number of papers published in 2001 divided by 17867. What is that? Total papers published in all the years taken together. Here you'll get the publication efficiency index is 0.79. Fine. And if you see here, the highest PEI is for 2009 and 2010. It has got 1.16, more than the average. Okay, and it is least in the year maybe 0.7 in first year, where you get comparatively less number of citations and the efficiency is less. So when your publication efficiency index is more, it means that your papers are well received, well acknowledged, and well cited by the people in the particular discipline. The same way, you can calculate PEI of a country also. You can see here, India, total publications, total citations, is output in 2020 and citations in 2020. Fine. So how to calculate PEI? It goes this way. F51, that is number of citations India received in 2020 divided by D51. What is D51? These are total citations received by India. This first portion. And second portion, E51. What is E51? Total output of India in 2020 divided by C51. Total output of India for all the years taken together. So if you see, the India's publication efficiency index is 1.50, relatively a very good efficiency in terms of number of citations received by Indian publications. Fine. So both are possible. You can create one table for authors and one table for, one table for countries and one table for year-wise publication efficiency index of a particular discipline or a particular author or a particular institution. So you can do all those kinds of calculations. Let me go to next one. AAI attractive index. It tells you what is the relative impact of a country's research output in a subject field as reflected by citations they received during the period. It tells you what is the impact relatively when you are comparing your performance with the rest of the world in terms of citation, how relatively you are good enough. Okay, you can do it with the attractive index. To what extent your papers are attracted by other researchers in the same field in terms of citation. Fine. So what is the formula? The formula says that citations for India in 2020 divided by citations of India during the entire study period. This first part of the formula divided by total world citations in 2020 divided by total world citations for the entire study period. Fine. So this normally is calculated for an individual specific field. You can see here. Let us say India, total publications, total citations, and this is total output in 2020 and total citations in 2020. How to calculate attractive index G20, that is number of citations India received in 2020 divided by E20. What is that? Total citations India had, and you take this as the first portion of the formula divided by 1424. What is that? 1424. I'm sorry, it's not 1424. I think it should be 1700. 1700. That is 170. That is total publications divided by then total citations. Let us check this one thing. No problem. Citations for a country in 2020. So we have citations called G20 divided by citations for that country to the whole period. So total citations India received was 1200. What is that? E20. So first portion is correct. G20 by E20. What is second part of the formula? Total world citations in 20. What is the total world citations? 10,100. So what is that? This is total world citations in 2020. If you take 2020, what is the total citations? 1424. I think my first number is correct. 1424 is the total citations in 2020 divided by total world citation. What is the total world citation? 10900. So this tells you what is the attractive index, to what extent our contributions, our publications are attracted by other researchers. Okay. Maybe these activity index, attractive index, affinity index, these things are the different variations, different terms given by different authors. Sometimes almost have similar kind of formula, similar kind of results, similar kind of calculations. Each author has got his own way of defining Scientometric indicators. Fine. Let me go to transformative activity index. I think I told you about activity index. I think couple of minutes before, I think I told you activity index. I think remember how we calculated activity index, right? If you take this one, TAI, that is a transformative activity index, same formula. Only thing is what we do is that instead of calculating activity index for a single year, we calculate activity index for blocks. You take 2001 to 8, 2009 to 16, you calculate the total number of publications of the entire block period. For the block period, research output for a few years, if you take, and if you calculate activity index, then that is called as transformative activity index. And very importantly, what you need to do is that after calculating activity index for two different blocks, you need to calculate change in TA, change in transformative activity index. That means F17, that is transformative activity index of one period, minus D17, transformative activity index of earlier period. So current period, current block minus previous block. So that the activity index is in minus. That means you're comparing the relative research effects of countries in different blocks. As far as India is concerned, we could see relatively lesser efforts in the second part of the block. That is what the transformative activity index is all about. Both TAI and AI same. Only thing is TAI is calculated for the blocks, and you calculate the change in the blocks. Fine. You can calculate for 3 blocks, 4 blocks also, depending on your nature of data. Then comes INI, Internationalization Index. It tells you number of international links divided by total number of papers to the rest of the world in the 100. Let us see an example. It's very simple to calculate. Internationalization Index. And these 2 or 3 indices, like Internationalization Index, and few 3 or 4, I think 2 or 3. These indices I have taken from a particular thesis, scientometric research work done by Mrs. Grace on infertility literature, a good friend of mine. Thank you, Grace, madam, for having given me this permission to use a couple of indices I have taken from your PhD research work. Thank you so much. This international index, let us see how to calculate. India has got 100 papers altogether, and out of which 29 papers are internationally collaborative papers. It's very simple. So what is our internationalization index? 29%. Out of total 100 papers, my 29 papers are internationally collaborated. For example, if you take USA, 300 papers, out of which 190 papers are internationally collaborated. So the internationalization index is 63.33%. Okay, it's very simple. Out of our total publications, how many percentage or how many papers are internationally collaborated? Okay, fine. Let me go next one, affinity index. It tells you what is the affinity between countries. So what is the affinity between myself, my country, India and USA, India and UK, India and Canada, India and China, in respect of publications in a chosen field. If you take a particular field of study, in that particular field, how many papers are contributed by India, joining hands with UK, USA, Canada, Sri Lanka. So to what extent there is an affinity between the countries in terms of publications. So affinity index, very simple to calculate. The formula says number of scientific links between country A and B divided by number of cooperative links between country A and the world into 100. So here I have just, let us see an example. I have given here India has got 2 not 2 publications, of which 56 with the USA, 89 with UK, 45 with Canada, 12 with China. Here I have taken only India's internationally collaborated papers. Okay, other papers are not taken into consideration. Okay, and here you can see the affinity index. See, India versus USA. How to calculate? D22. That is, what is D22? This is D22. How many papers India had collaboratively published with USA? 56 divided by 202. What is 202? The total output of India. India has collaborated with many countries. What is total output? 202 into 100. That means out of totally collaborated papers of India, how many papers are collaborated with the USA? A simple percentage calculation. We have 27.72%. If you see the affinity index of the countries taken together, India's affinity is more with the UK because we have produced a 44.06 with the UK. Okay. If you take USA, they are closely associated with the UK and they are least associated with China. If you take China, they are close with Canada and they are least close with UK. So this we can find out to what extent countries are having affinity between them in terms of number of papers produced by them. It's a very good index, affinity index. Then comes RQI. We have got three more indices. I just completed. RQI, Relative Quality Index. It tells you the ratio of proportion of number of cited publications to total citations of the year. First quote. And second question is proportion of total cited publications to total citations. This is also a measurement of quality. We talk about quality, we talk about citations. Okay. What is the formula? Very simple. Number of cited publications in 2020 divided by total citations of 2020. First portion of the formula. Total cited publications divided by total citations. This is the second part of the calculation. So let us see. In 2001, I published 1, 2, 7, 8 papers, out of which 730 papers were cited. That means remaining papers were not cited. And out of these 730 papers which got citations, the all 730 papers together, they were able to get 11440 citations. So what is my RQI? It says D23. What is D23? Number of cited publications divided by E23. Total citations received by 723. That is 730 divided by 11440. First part of the formula. Divided by 4151. What is that? Total number of cited publications divided by 70505. Total citations. Fine. That means we don't take into account all the papers published in a year or in a country. We take only those papers which receive citations. Okay. In the previous cases, we have taken total papers, total citations, total output of a country, total citations of a country. But here, in the relative quality index, we take into account only the papers which were cited. We take cited publications, we take number of citations, and we do a calculation. So this relative quality index for all the years you can calculate, for all the countries, for each and every country you can calculate, for an institution you can calculate, for an individual you can calculate, you can find out the relative quality index. Then comes RAI. This is relative activity index. For example, I will give an example. India has got 120 papers in computer science totally, for example, in a particular year. Out of these 120 papers, 28 papers were published on the subject cloud computing, 12 were published on artificial intelligence, 35 on machine learning, 45 on open source software. Fine. So this is what India has produced in computer science. Okay. Now, I want to calculate the relative activity index. So what is the performance of India in different sub-disciplines of computer science in a given period of time? Fine. So let me calculate for relative activity index of different fields. I take for cloud computing, the formula goes this way. The analyzed units world share of publications in a given field divided by the units world share of publication, all the fields taken together. For example, as far as cloud computing is concerned, what is the formula you need to use? D15. What is D15? This is the number of papers published by India during the given period of time on cloud computing divided by C15. What is 15? Total papers published by India in computer science. So total papers and number of papers published in cloud computing. Very simple calculation. Only thing is they have a very big name and formula for all things. Okay, nothing but the proportion of cloud computing papers published by India in a given period of time to the total papers published by India in the big domain called computer science. So if you see the relative activity index, we could see here, and machine learning and open source software are the most prominent research areas of India, because our relative activity index is higher in terms of voices. And if you take UK or USA, their relative index is strong in cloud computing. They're very strong in cloud computing. So this you can find out the subdomains of a particular research area where a particular country is more dominant. Either you can do it for a country, you can do it for an institution, you can do it for an individual. You can calculate the relative activity index. Fine. Let us move on to the last scientometric indicator called time series analysis. Okay. This is a very popular one, and this particular indicator is used to find out, to estimate what would be the future research output of a particular discipline or a particular country, maybe after 10 years, maybe after 20 years, maybe after 30 years. So how we can estimate the future productive output of a particular discipline. So for example, I have taken a disease called vertigo research output from 1992 to 2019. For 28 years, I collected data. So serial number, year, X is nothing but year, 0. You have to start from 0, you have to go to 27. There are 28 years, you start from 0 and go up to 27. Then capital Y, it tells you number of publications. 1992, 55 papers are published in vertical research output. So year-wise research output should be placed under Y. Then comes capital X. Okay, it is the one you need to do by yourself. If there are 28 years, you divide it into 2 off. 14, 14. So you go to 14th year and you type minus 0.5 and you keep on adding 1. 0.5, I'm sorry, for there are 28 years, you have divided into 2, 14, 14. For the 14th year, you are given minus 0.5. Then 13 minus 1.5, minus 2.5, minus 3.5, keep on increasing 1. And from 15th year onwards, you have to add 1, 1, 1 in the 0.5, 1.5, 2.5. That means earlier years will have minus symbol and later years will have plus symbol. And if you see here, it starts from minus 0.5, it goes up to minus 13.5. In the latter portion, it starts from 0.5, it goes up to 13.5. These things are in positive. So same set. Some people say that, sir, we need not add 1, we can add only 0.5. We can do that also. No problem. For example, instead of adding 1, you can add only 5, minus 5. For example, 0.5, 1, 1.5, 2, 2.5. Only thing is, there should be an equal difference between the 2 years. Either you add 0.5 or you add 2 or you add 1, but add uniformly. But normally we take 1. We have 1 equal distance between 2 points. Fine. Fine. So this is calculated. This we are writing it. Then EXY. So minus 13.5 multiplied by 55. You get XY for all years. You can calculate a simple calculation. Then X square. 13.5 into 13.5, both are minus or result in positive. This way you calculate X square for all years. So now we calculated sigma X, sigma Y, sigma capital X, sigma XY, sigma X square. So we have calculated all totals also. Now let us go for the estimation. So what is the least linear equation? It says that Y is equal to, Y means the future output, how much it would be, is equal to A plus BX. So A and B are values we need to obtain, and X is the year. What is A? A is equal to sigma Y by N. What is sigma Y? Sigma Y. What is Y? This is Y. What is sigma Y? G36, 7201 divided by, what is N? Number of years. How many years? 28 years. So 7201 divided by 28, you get A. 257.1786. So A value is calculated. Let us calculate B value. What is B? Sigma xy. What is xy? This is xy, I column. What is sigma xy? 27608. So I 36. This is the sigma xy divided by sigma x square. What is x square? This x square, and this sigma x square J 36. J 36. Okay, sigma xy divided by sigma x square is equal to B. So we have calculated sigma, we have calculated A and B. Fine. Now we need to calculate X. So X is the year, future year for which you need to estimate your research output. Here I had seen two different calculations in many research papers. The very few research papers or theses have this kind of calculation in the sense. For example, you want to calculate how much would be the output of vertical research in 2025. How to calculate? It says that A plus BX. What is A? 257.1786. So F41. F41 is the A value plus what is the B value? F42, 15.11138. So F41 plus F42 into, when you're calculating this year, I give you two different methods of doing it. The first method says that future year for which you want to calculate the research output minus the first year. But the first year 1992. If you want to calculate the future output for 2030, then 2030 minus 1992. If you want to calculate it for 2040, then 2040 minus 119. That means the future year minus the first year is being taken to calculate the research estimated research output. You can see the estimated research output is slightly higher. 2025 it would be 755, 2040 it would be 982 approximately. Fine. But in a good number of these, I would see they have not used the beginning year 1992. Instead, they use the middle year. For example, if you want to calculate the future output of 2025, what it is that you take A value plus B value multiplied by 2025 minus, instead of writing 1992 as we have seen the previous case, you need to write 2006. What is this 2006? That is a 15th value. So there are 28 years. You divide it into 2 of 14. So what is the 15th year? 2006. After dividing into 2, what is the first year? 2006. So instead of using 1992 as even this particular formula, here you need to use 2006. The 2030 minus 2006. 2040 minus 2006. 2050 minus 2006. See, both kinds of calculations are there, but in most of the cases I had seen the use of the middle value. If you see here, comparatively the future estimated output is comparatively less. So this way you can calculate, you can do time series analysis for entire output. You can take only single author publications and you can calculate time series analysis. You can take only joint author publications and you can calculate time series analysis. So whatever kinds of future estimation you want to make, you can achieve it with the help of this time series analysis. So dear friends, till now we have seen how to calculate different kinds of scientometric indicators with MS Excel. I hope we will be sharing with you this particular Excel sheet so that you go to any other databases, you collect data and you fit the data in these Excel sheets and you get the answers for all these scientometric indicators. And if there is any suggestions, if you want to add more scientometric indicators, you are most welcome, and best of wishes. Thanks so much.